Welcome to Creative World. In this video, we will learn and implement a circuit that helps us to protect polar capacitors used inside electrical circuits. We know that there are two basic types of capacitors according to polarity: polar capacitors and non-polar capacitors. Difference between these two capacitors is that polar capacitors have defined polarity of their terminals, while non-polar capacitors don't have any polarity of their terminals. Which means we have to be careful while connecting these polar capacitors in the circuit. If we applied reversed polarity of voltage across these capacitors, they might burn and explode. On the other hand, non-polar capacitors don't have any polarity limitations. They might be connected in any direction in a circuit. Now, a question may arise: non-polar capacitors are available and they don't have any polarity limitations. Instead, why we use polar capacitors? To answer this question, I will make another video. So stay tuned with Creative World. Their respective symbols used in electrical circuits are shown here. This symbol is for non-polar capacitors and this symbol is for polar capacitors. As we discussed earlier, polar capacitors have defined polarity of their terminals. That's why their symbol also includes this information. This is the plus terminal of polar capacitor and this is negative terminal of polar capacitors. Now we will see the circuit of polar capacitors. In this circuit, a polar capacitor is connected across a 12 volt source. And this capacitor will work fine because right polarity of voltage is applied across its terminal. Now assume another case when someone accidentally applied reverse voltage across a capacitor. Capacitor will instantly blown and get fired. This event can damage other sensitive components used inside circuit or might lead to a big fire. This fire and burns are small for smaller values of polar capacitors. But think about it, if we are dealing with large polar capacitors in millifarads, their burns and fire will also huge and they might cause injuries to workers as well. So to avoid these issues, there is a circuit which can protect circuit as well as individual working on it. Now learn about the working of the circuit. This diode is connected in reverse biased direction parallel to the polar capacitor, and this is the fuse which will burn in case of reverse polarity of applied voltage. Whenever these voltage will be applied in right direction to the polar capacitor, in that case this diode will become in reverse bias direction. All current will be passed through this fuse to the capacitor and rest of circuit. And the capacitor and rest of circuit will work in normal condition. Now assume that someone accidentally applied reverse voltage across this polar capacitor. In that case, this diode will become forward bias and it will short the power supplied voltage through this fuse. Due to excess amount of current, this fuse will blown and it will protect polar capacitor from reversed voltage by opening itself. Now we will move towards simulation to see the implementation of the circuit. Circuit for the protection of polar capacitor is designed here. This is voltmeter which will measure the voltage present across polar capacitor. This is a 1 kilo ohm load connected across polar capacitor and this is a polar capacitor. This terminal of polar capacitor is positive and its value is 100 microfarad. One diode with number 1N4007 is used and this is the internal resistance of this diode. A fuse is also connected in series to protect the circuit from overcurrent. Here two voltage sources are used to switch between forward and reverse polarity of voltages to this circuit. First we will run the simulation in normal state whenever the polarity of voltage is similar to the polar capacitor. In this case the circuit will work in normal condition. This diode will be reversed bias and voltage will be appearing across this capacitor. And whenever we switched from forward to reverse bias voltage using this SPDT switch, this diode will short the supplied voltage through this loop and excess amount of current will pass through this fuse. It will burn and open the circuit to protect polar capacitor from reverse voltage. Now let's see the simulation. This is the normal condition when forward voltages are applied to circuit. Voltage across polar capacitor are 12 volt and fuse is injected. This diode is reverse biased, so it is working as an open circuit. All current is passing through fuse, capacitor and load resistor. Now we will switch from forward to reverse voltage. In this case, you may see what happens. If you observe, our fuse is burnt and it opened the circuit and secure polar capacitor from reverse voltages. Once again, see the simulation. This is normal state. Everything is working fine. But whenever we reverse the voltage, this diode will conduct and it will short the supplied voltage through fuse, and due to excess amount of current, this fuse will be burnt and it will secure the polar capacitor from burning. So this was all about today's lecture. Thank you. See you again in next video.